The National Electrical Code, or NEC, explicitly recognizes exothermic welding as one of several acceptable methods for connecting ground conductors and bonding jumpers. Refer to NEC sections 250.8 and 250.70. Emphasize that the specified pressure connector, such as a Burn DXC high tap, is Underwriters Laboratories, or all, listed for direct burial and concrete application. This UL listing indicates its suitability for harsh environments. Present evidence from studies or industry experience demonstrating the long-term reliability of pressure connectors in underground grounding applications. Provide data on the corrosion resistance of the copper ground wire used in the pressure connectors, showing that it is resistant to the anticipated conditions. Explain that while a local electrical plant check requires exothermic welding, it does not prohibit other NEC-compliant methods. Argue that the 2002 NEC should take precedence over local ordinances as long as the NEC requirements are met. Emphasize the importance of ensuring that the grounding system is safe and reliable, and that the preferred method should be based on technical merit rather than personal preference. Firstly, if these arguments do not persuade the authority having jurisdiction or urge, you may consider appealing the decision to the local building authority's governing body. Secondly, consulting with an attorney specializing in construction law can be beneficial. Thirdly, seek an independent review of the design by a qualified electrical engineer. If the AHJ insists on exothermic welding, consider the following mitigation strategies. Firstly, explore the use of exothermic welding on the main grounding connections while using pressure connectors for smaller ground wires. Secondly, specify frequent periodic maintenance and inspection of the grounding system to ensure its continued integrity. Thirdly, use corrosion-resistant materials for all components of the grounding system. Grounding systems are critical for electrical safety. Properly installed grounding systems provide a low impedance path for fault currents, minimizing the risk of electrical shock and fire. The NEC outlines specific requirements for grounding to ensure safety and reliability. These requirements cover various aspects of grounding, including grounding electrode systems, grounding conductors, and bonding. Grounding electrode systems must be installed per NEC section 250.50. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. The selection and installation of grounding electrodes must comply with NEC requirements to ensure effective grounding. Grounding conductors connect equipment and systems to the grounding electrode. The size and type of grounding conductors must comply with NEC tables, such as Table 250.122, based on the rating of the overcurrent protection device. Proper installation of grounding conductors is essential to provide a lower impedance path for fault currents. Bonding involves connecting metallic parts to create an electrically conductive path. Bonding reduces voltage differences and minimizes the risk of electrical shock. NEC Section 250.92 covers bonding requirements for services, while Section 250.96 covers bonding requirements for other systems. Exothermic welding is a method of creating a permanent metallurgical bond between conductors. It involves using a chemical reaction to generate heat and melt the conductors together. Exothermic welding provides a reliable and corrosion-resistant connection, making it suitable for grounding applications. Pressure connectors, such as compression connectors and bolted connectors, are commonly used to connect grounding conductors. These connectors must be UL listed for grounding applications and installed per manufacturer's instructions. Pressure connectors provide a convenient and reliable method for making grounding connections. Corrosion is a major concern in underground grounding applications. Soil conditions, moisture, and chemical exposure can accelerate corrosion of grounding conductors and connectors. Selecting corrosion-resistant materials and implementing corrosion protection measures are essential to ensure the long-term integrity of the grounding system. Regular inspection and maintenance are crucial for maintaining the effectiveness of grounding systems. Inspection should include visual examination of grounding connections, testing of grounding electrode resistance, and verification of bonding connections. Maintenance should address any issues identified during inspections, such as loose connections or corrosion. The authority having jurisdiction, or OJ, plays a vital role in ensuring compliance with electrical codes and standards. The AHA reviews electrical plans, inspects electrical installations, and enforces code requirements. Effective communication and collaboration with the AHA are essential for obtaining approval of electrical designs and installations. Understanding the NEC requirements for grounding is essential for electrical engineers, contractors, and inspectors. Proper grounding practices ensure electrical safety and minimize the risk of electrical hazards. Staying up to date with the latest NEC revisions and industry best practices is crucial for maintaining a safe and reliable electrical system. When dealing with grounding requirements, it is important to understand the specific requirements of the NEC, the suitability of different connection methods, and the importance of corrosion protection. By addressing these considerations, you can ensure a safe and reliable grounding system that meets the needs of your application. The NEC provides detailed requirements for grounding and bonding to ensure electrical safety. Article 250 covers the general requirements for grounding and bonding, including the types of grounding systems permitted, the methods for grounding different types of equipment, and the requirements for grounding electrodes. Understanding these requirements is essential for designing and installing safe and effective grounding systems. Grounding electrode systems are used to connect the electrical system to the earth. The NEC specifies several types of grounding electrodes, including metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. The selection of the appropriate grounding electrode depends on the specific site conditions and the requirements of the electrical system. Grounding conductors are used to connect equipment and systems to the grounding electrode. The NEC specifies the size and type of grounding conductors based on the rating of the overcurrent protection device. Grounding conductors must be installed per NEC requirements to ensure a low impedance path for fault currents. Bonding involves connecting metallic parts to create an electrically conductive path. Bonding reduces voltage differences and minimizes the risk of electrical shock. The NEC specifies bonding requirements for services, equipment, and other systems. Effective bonding is essential for maintaining a safe and reliable electrical system. Exothermic welding is a method of creating a permanent metallurgical bond between conductors. It involves using a chemical reaction to generate heat and melt the conductors together. Exothermic welding provides a reliable and corrosion-resistant connection, making it suitable for grounding applications in harsh environments. Pressure connectors, such as compression connectors and bolted connectors, are commonly used to connect grounding conductors. These connectors must be UL listed for grounding applications and installed per manufacturer's instructions. Pressure connectors offer a convenient and reliable method for making grounding connections, but must be carefully selected for the application. Corrosion is a major concern in underground grounding applications. Soil conditions, moisture, and chemical exposure can accelerate corrosion of grounding conductors and connectors. Selecting corrosion-resistant materials and implementing corrosion protection measures are essential to ensure the long-term integrity of the grounding system. Regular inspection and maintenance are crucial for maintaining the effectiveness of grounding systems. Inspections should include visual examination of grounding connections, testing of grounding electrode resistance, and verification of bonding connections. Maintenance should address any issues identified during inspections, such as loose connections or corrosion. The authority having jurisdiction plays a vital role in ensuring compliance with electrical codes and standards. The AHA reviews electrical plans, inspects electrical installations, and enforces code requirements. Effective communication and collaboration with the AHA are essential for obtaining approval of electrical designs and installations. When designing and installing grounding systems, it is important to consider the specific requirements of the NEC, the suitability of different connection methods, and the importance of corrosion protection. By addressing these considerations, you can ensure a safe and reliable grounding system that meets the needs of your application. In petroleum refinery environments, the presence of hydrocarbons and other chemicals can accelerate corrosion of grounding conductors and connectors. It is essential to select materials and installation methods that are resistant to corrosion in these harsh environments. Consider using stainless steel or copper-clad steel grounding conductors and connectors. Also, consider using epoxy-coated or otherwise protected connectors to provide additional corrosion resistance. Regular inspection and maintenance are particularly important in petroleum refinery environments to detect and address any signs of corrosion. The NEC specifies requirements for grounding and bonding in hazardous locations, such as petroleum refineries. These requirements are designed to minimize the risk of ignition of flammable gases and vapors. Grounding and bonding conductors must be sized and installed to provide a low impedance path for fault currents, and all metallic equipment must be bonded together to prevent the buildup of static electricity. Effective communication and collaboration with the authority having jurisdiction are essential for ensuring compliance with the NEC and other applicable codes and standards. Be prepared to discuss the technical basis for your design choices and to provide documentation to support your arguments. If you disagree with the AHJ interpretation of the code, you have the right to appeal their decision to a higher authority. When appealing a decision, it is important to present a clear and concise argument supported by relevant code references and technical data. Grounding is a critical aspect of electrical safety, and it is essential to design and install grounding systems that comply with all applicable codes and standards. By following the recommendations outlined in this discussion, you can ensure a safe and reliable grounding system for your application. The reliability of grounding connections is paramount for maintaining electrical safety and equipment protection. Over time, connections can degrade due to corrosion, vibration, or mechanical stress, leading to increased resistance and reduced effectiveness. Therefore, regular inspection and maintenance of grounding connections are essential. Visual inspections should be conducted periodically to check for signs of corrosion, loose connections, or physical damage. Connections should be tightened or replaced as needed to ensure a low impedance path to ground. In harsh environments, such as petroleum refineries, more frequent inspections may be necessary. In addition to visual inspections, electrical testing can be performed to verify the integrity of grounding connections. Ground resistance testing measures the resistance of the grounding electrode system to earth, providing an indication of its effectiveness. Continuity testing verifies the continuity of the grounding conductors and bonding connections, ensuring a low impedance path to ground. Infrared thermography can be used to detect hot spots in grounding connections, which may indicate loose connections or corrosion. Proper documentation of grounding system inspections and maintenance is essential for tracking the condition of the system and identifying potential problems. Records should include the date of the inspection, the findings of the inspection, and any corrective actions taken. Grounding system design should consider the potential for future maintenance and repairs. Connections should be accessible for inspection and tightening, and grounding conductors should be routed in a way that minimizes the risk of damage. Using corrosion-resistant materials and proper installation techniques can also reduce the need for maintenance. When selecting grounding connectors, it is important to consider the specific application and the environmental conditions. UL-listed connectors should be used to ensure that they meet industry standards for safety and performance. Compression connectors provide a reliable and corrosion-resistant connection when properly installed. Bolted connectors should be torqued to the manufacturer's specifications to ensure a tight connection. Exothermic wells provide a permanent and corrosion-resistant connection, but require specialized equipment and training to install. When dealing with the AHJ, it is important to be prepared to discuss the technical basis for your design choices and to provide documentation to support your arguments. If the AHJ has concerns about the reliability of pressure connectors in a particular application, you can provide data on the performance of these connectors in similar environments. You can also offer to implement enhanced inspection and maintenance procedures to address the AHJ concerns. In some cases, it may be necessary to compromise with the AHJ and the grounding methods used. For example, You may agree to use exothermic wells for the main grounding connections and pressure connectors for smaller branch circuits. The goal is to ensure a safe and reliable grounding system while also meeting the requirements of the AHJ. Regular maintenance and inspection is necessary for any grounding system to make sure it stays effective. This helps with catching any issues, such as loose connections or corrosion, that may happen as time passes. This can be done through visual inspections, electrical testing, and infrared thermography. When problems are identified, proper documentations and corrective action are implemented. In any high corrosive environments, additional protection is necessary. These mitigation measurements include epoxy-coated connectors and corrosion-resistant materials. The goal is to ensure a long-lasting ground system that holds up over time, even in hard-to-deal-with areas. Understanding the importance of consistent monitoring and following the AHA guidelines is key in guaranteeing the systems stay effective and meet the safety standards.